So now we're actually going to be in the exciting section of actually building and assembling what we've learned so far. So we have our Arduino right here. We have our resistor, which is again recommended to be 300 to 400 ohms. Uh, we have our LED right here. We have a connecting USB right here, where I'm going to be connecting my Arduino to a laptop. And I have my Arduino breadboard right here. Okay. And then I have my connecting wires. Okay. So let me begin by connecting the Arduino with the breadboard. If you have an Arduino Uno, you don't need to connect your Arduino with the breadboard. All you need to do is a hole again. So all you do is again connect it directly to a connecting wire. Okay, so second thing I'm gonna need to do, we're trying to build a circuit actually. So let me bring the circuit right here. Okay, so we've got our Arduino connected. We want to connect it to the 5 volt. So let me go right here and let's try to connect it to the 5 volt. There's the 5V connected right there to the 5 volt. Okay, let's say put it around 25. Okay, just put it randomly on 25. Then now what we want to happen is we want to connect it to a resistor. Okay, so let me bring my resistor right here, bring it right here, and let me just try to connect it a bit. If you can see it. Okay, so one thing you notice is I connected it across. So as you remember, this row is connected, this row is connected, but these two rows are not connected to each other because they have a gap, as I told you guys earlier. So if I connected it, let's say, in the same row, okay, horizontally in the same row, let me just make this a bit more thin. Let's say connected it this way, okay? If let's say the resistor is not connected properly, sometimes this happens. You have to push it in, okay? And if the resistor is not connected properly, what is it going to happen is basically this type of circuit. We have our, again, Arduino right here and directly connected to what? To our LED. So it's going to fry our LED with a one that's happened. Again, so if I connect it abroad though, if I connect it somewhere where it's not connected, again, let me just make this a bit more wide. It's a bit of a hustle to even connect resistors, to be honest. So you guys can see I connected it abroad is current will flow like this from the 5 volt to the connecting wire right here, goes horizontally, and let's see it's not connected right here. What is going to basically happen is it's not going to what? Conduct electricity. So at the worst case scenario, if you connect it like this, is nothing happens. So the LED does not light up. It's not going to get fried, but it's not going to light up. All you need to do again is connect it properly and um, you're good to go. So we want to connect it what? When we're connecting a resistors, we want to connect it across. If not, we can even connect it vertically, okay? Because again, as I said, they're not connected. So we want this one leg to be on the connected side and one leg to be on the side that's not connected anyway with the again the circuit. Okay, with that in mind, let me just bring my LED. And before actually doing that, we first need to identify, let me just make this a bit more wide. Uh, we need to identify which one is the positive sign and the negative side. As I've told you guys earlier, the longer side is the positive, and we want to connect it to the positive terminal. As I said again, the P type, okay? This is the P type, and we want to connect the negative side with the negative terminal, the N type. So we want the longer side to be the direction of the positive. So I have the longer side right here, and I want to connect it right here, as you guys can see. Okay, now finally, we connected our Arduino, current is flowing, we've connected our resistors, we've also connected our LEDs, the positive side and the negative again. So if you look right here, actually, this is the positive side, okay? If you look at it even diagrammatically, it's positive right here, and we have the negative right here, okay? So again, it's going to go all the way right here and to the negative terminal. And how do we get the negative terminal in an Arduino is, let me go all the way. You guys can see it. There's a sign that says GND. You can see it right here. GND stands for negative or ground, okay? So if I put GND right here, it basically means is negative. There's no other meaning towards it, all right? So I want to connect to the negative side of my LED. So all I need to do is touch this, and we're done building our first circuit. So right now, let me finally bring our connecting USB. So let me connect it to my laptop. Okay. Then let me connect my Arduino. There you have it. We have our first up and running LED circuit. Let me turn off the lights so you guys can see it better. So there you have it again. This is a simple circuit. What is going on? Oh, you see resistors that I was talking about earlier? Sometimes they disconnect when we move them again. And what happened was, again, it turned off, but our LEDs, again, were not fried, as I said again, because current cannot flow through. Okay, so with that in mind, see you on the next project. In our previous section, we built a simple circuit that lights up an LED. So let me bring it right here. So if you look close enough, we used our Arduino as a power source, nothing more than that, something that outputs 5 volt. We only used it as something that outputs 5 volt, but also can output a voltage. A battery can. So in this case, we can build the same exact project if we have a 5 volt battery. Okay, so instead of using an Arduino as a power source, we can use a battery. Right here, I have a 1.5 volt battery, as is just found commonly inside of the remotes and all the things that we use. So I'm going to use a 1.5 volt. But this means that current is going to be less. Okay, so voltage is directly related to current. So I'm going to have less current. Basically, the light is going to be a bit more dim. So to actually demonstrate that, let me turn off the light. Maybe then you can see it. If you cannot, let me just bring this paper right here and try to overlay it with the paper. Maybe then you can see it. Can you see it? Okay, there we go. And let me just turn it off and turn it on so you can see the difference. Can you notice it? There we go. It's very dim though. You can see it if you was actually in a dark environment. But anyways, this raises the question, why not use batteries instead of Arduino? Because when you look at batteries, they look more reliable, they're cheaper, and again, they're easier, far easier to just move from place to place. So they're more convenient. So when you look at Arduino right here, we have all these things. You really need to be careful with Arduinos. Not only that too, but they're really expensive relative towards a battery. So this raises the question, why Arduino? Why are we using an Arduino? So one thing you guys need to know about Arduino is Arduino acts as a power source, but it's just definitely more than just a power source, all right? So it is a power source. It acts like it, but definitely it is more than just a power source. Even by looking at these pins and looking at all these things that we have right here, we can see that it's just definitely more than a power source. We're only talking about the 5 volt right here. So when you look at all these things that we have right here, it is definitely more than a power source. So what is the purpose of an Arduino? Arduino is used to code our electrical components. For example, let's say I wanted to code this so that it turns on and off every second. So it's going to turn on for a second, then turn off for another second, turn on, turn off, doing it in a loop. Okay, so it's going to turn on for 1 second, turn off for 1 second, turn on for 1 second, turn off for 1 second, and keeps going on in a loop. So how do I do this using a battery? I have to physically come in right here, turn it off, turn it on, count a second, turn it off, count a second, turn it on, count a second, turn it off. And obviously, this is not coding. But with our Arduino, we can set this up. We can set up we can set this up so that we can actually code it to actually make it blink. So we're gonna turn it on for 1 second, turn it off for 1 second. We can do this using an Arduino. So Arduino, what does it do? Something important that it does is it lets us code our physical components. I'm sure you use websites and applications and they're coded digitally. So what if you wanted to code our physical components? For example, let's say we're working on a robot or some other projects. This is where Arduino comes in.